Pivigo is the data science marketplace and training provider. What that means is that we work with companies across the globe to help them innovate with data science applications, making use of their data for better value and making customers happy. And what's unique about the way we do that is that we connect them to our global community of freelance data scientists. So we have over 9,000 data scientists, experts on our platform that we bring in to work on these projects. We have worked with about 220 projects to date, with about 120 different clients from every industry and every sector you can imagine. And we have done many different types of projects, many optimization projects, marketing projects, predictive maintenance, and of course, what we'll hear about here, recommendation systems. So that's Pivigo. And Rob, tell me about Mindful Chef.
So Mindful Chef is a healthy recipe box company. We deliver all the ingredients that customers need to make healthy evening meals at home. Customers typically choose 2 or 3 recipes per week out of a maximum of, we have 16 recipes on the menu to choose from. And that provides us with lots of challenges around how do we optimize forecasting, and how do we also optimize the recipes that we recommend for individual customers. We've been going for about 5 years, and we have shipped about 6 million recipes to date. So that's 6 million recipe selections that customers have made from our menu each week. And sort of in the middle of last year, we thought we should really be getting a little bit better at personalizing the Mindful Chef experience for different customers, either on an individual basis or on a group basis. And we thought, well, we probably have a lot of data that we can anonymize and try and analyze. And we asked Kim and her team whether they could help us with that.
Indeed, and this particular project that we did was actually part of a program that we run in Pivigo called Science to Data Science, or S2DS. Now, S2DS is a very special way that we run projects and something we really enjoy. It's a program that goes on for 5 weeks, where we bring on PhDs and MSCs, super smart people who come with technical backgrounds, but who may want to make a transition from academia into industry as data scientists. And what we do is, for these 5 weeks, these super smart people, they team up in teams of about 3 or 4, and they work with a company to actually deliver a project such as the one we're about to talk about today. All the IP, all the outcome from the project goes to our partner, and we have run this program over 16 times now and taken almost 700 PhDs and data scientists through that program, and it's been a great success. And I think what it really demonstrates, and what we'll see in this case as well, is how much you can do in actually quite a short period of time. What was very impressive about this particular team was how they went from knowing nothing about the company or this particular problem through to delivering a fully packaged solution that was ready for Mindful Chef to implement within these 5 weeks. Briefly, how they laid that out, that project, was in week 1, they started with exploration. So looking at the data, trying to figure out, what is this? How does it work? What are the challenges around creating this product? And they also actually started on their first model in that first week. The second week was about designing. So looking at feature engineering, looking at what do we actually need to model into this. And by the end of the second week, they had their first full model ready. Week 3 was then about deployment. So looking at how do we architecture this into such a way that it will be useful to Mindful Chef at the end, that it won't be just a theoretical algorithm for this is how we could do this. It's actually something that they could implement straight away. So starting to build that and testing it. And week 4 then, and I say week 4 because of 1 week roughly was lectures, so it was effectively 4 weeks on the project. The fourth and final week was then just around actually documenting what they had done, figuring out how to launch this application, and making sure that the handover was ready for Mindful Chef. And throughout all of that, of course, tweaking their model and making it as useful as possible. So basically in week 1, they had a working model. In week 2, they had more or less their final model. In week 3, they had the local deployment done, and week 4, they had the full deployment done. So that's how this worked. Now, of course, as I mentioned, there were challenges to this project. And specifically, there were, I will get to the challenges in a second. Sorry, I'm running ahead of myself. I'll let Rob tell you exactly what the problem was about first.
So when we set an objective for the team, and there were 4 of them on the project, all bringing slightly different skills across the sort of whether it's maths or previous data science experience, or even engineering experience to actually build the production model. We said that out of really the objective for us was to give each user a personal recommendation based on their historical choices. So the way that our system works is that recipes are assigned to customers 8 weeks ahead of delivery of that box. So 56 days before delivery, our system goes through and allocates recipes based on a number of like relatively rigid criteria based on food preferences, some personal choice, like in terms of like plan that you sit on, and then each customer then has the next 56 days to either keep those recipes or to decide that they want to change them. So the objective that we said was, well, actually, we now only recommend recipes for a number of like groups, like big groups of customers. So lots of customers get exactly the same recommendation. And really, we want to personalize that and be able to, at any given point, rank the 16 recipes that we have on offer for every individual user. And we also want that ideally delivered via an API that can sit on our servers, so we can ping the API with a user ID, and that API can go and collect the user's previous choices and return us back the list of 16 recipes in the right order that we should recommend them.
Yes, so those challenges that I mentioned, they were very exciting challenges for our team to dig into. And specifically, some of them were quite unique to the Mindful Chef scenario. So number 1, there was no menu overlap. So from 1 week to the next, the entire set of recipes could change. And if you compare that to something like Netflix or Spotify, where the inventory of content, it does change, but only small additions to it. Most of it stays the same all the time. It makes it very hard to recommend something when there is no overlap with previous weeks. It also means you can't use something out of the box. You need to create something that is unique to the business. So that was challenge number 1. Challenge number 2 was around high-dimensional data. So if you think about the sort of recipes we're talking about here, it will have a set of ingredients, it will have a set of descriptions, words, it will of course have images, it will have number of steps involved to create the meal, and all of these sets of data, all of these features have very varying length, and there's varying amounts of them for each meal. On top of that, you can think of the user themselves having very variable set of data. So how long have they been with Mindful Chef? What have they picked before? What have their preferences been, etc. And putting all of this together meant that it could be up to 100,000 features for each recommendation decision. So that was challenge number 2. And then finally, challenge number 3 is what the team lovingly called the Big Mac problem, which is if you always pick a chicken dish, for example, does that mean you only want to eat chicken? Or does that mean it's sort of comfortable for you to pick another chicken dish, or should Mindful Chef challenge you then to try something different, or is it better that you stay in that zone? And recommendation systems have a tendency to recommend in the end the same content that you've liked before and not really challenging you. And this, of course, would be a challenge here too. So how to deal with all of these challenges? Well, the first thing to especially look after question number 1 and 2 around the no overlap and the dimensional data, the team, what they did was that they basically tried to collapse all of those dimensions into smaller and more descriptive dimensions. So we have an example here. Let's say that we put all of our meals into 2 dimensions that we call meatiness or soupiness. So you can think of the chicken soup, it's got meat in it, it's a soup, so it's going to be top right-hand corner. Vegetable soup, no meat, but soup, top left corner. Chicken drumstick is not a soup, but it's meat, so bottom right corner. And grilled tofu would end up in the left bottom corner. This is a way to then, as I said, collapse those big dimensions into smaller dimensions. And so that solves problem number 2. And now what we can do is, let's say that we have 2 completely new dishes that we've never had before. In this case, chicken stew and vegan chili. We can actually, based on these dimensions, put them into this diagram, and we can see where they lie nearer to another point. It's likely that someone who likes one might like the other. So with this sort of system, it was possible to look after problem number 1 of cold start every week, new menu every week, and question number 2 around high dimensionality data. It still leaves us with the Big Mac problem of what do we recommend? Should we only stay in the top right corner because you've only picked top right corner before, or should we encourage you to try other corners of the diagram? What the team developed there was what they called a curiosity parameter. And basically they looked at how does a customer or a user go through this type of diagram over time? Are you the kind of person that will slowly move little incremental steps from one point to the next, or are you a more random taster that will jump widely across the diagram from every day or every order? And this tells the team something about your personal preferences and how curious you are. And by the way, there's no emotion in that. You are who you are, and all Mindful Chef wants to do is make sure that you get the type of food that you enjoy. So what the team did here was to create this curiosity parameter to look at basically the distance between points within this type of diagram. So what they then did was they started actually feature engineering and looking at which features in all of this large dimensional space are really important when it comes to a customer making their decision. And very interestingly, they found that actually the size of these jumps are super, super important. So delta 1 and delta 2 in this diagram are the sizes, so the average distance in those jumps that a customer made within the last 2 weeks. And combining those together, they defined this curiosity parameter, which was the average distance between jumps. And as you can see, these 3 are the top most important features in terms of recommending the next recipe for you as a customer. And much more important, for example, than the number of calories in it or the time it takes to cook it or whether you said you were a vegan or not. So that is obviously a very important and an interesting insight into how customers like to choose their dishes. So the next question then for the team was, well, okay, from this we can now build a recommendation system, but how can we actually measure the success of that recommendation system? When we look at how these choices are made, they are not sort of Tinder style where you swipe left or right and you may end up with no dates or you may end up with many dates. That is not acceptable in this case. In this case, the customer goes in and has to pick, say, 3 choices out of 10. And so instead it becomes a ranking problem. So obviously you want to rank the top 3, and anything below that will not be chosen. And so what the teams ended up using was something called a map at K algorithm that actually measures the success of these types of sorting algorithms or ranking algorithms. So the map at K score will tell you how well the algorithm did. The team ended up trialing several algorithms, and if, for example, the choices were allocated completely randomly, this map at K score would be 0.39. So that would be the baseline. That's basically, we're not going to guess at all. We're just going to randomly give you some food and hope that you like it. And that was obviously the score to beat. Now, even before we started, Mindful Chef had their own allocation algorithm assigned. And this one already improved on that random allocation with about 15%. So actually, that's the score to beat. We want to obviously end up with something that's better than what already exists. Now, the team used several different algorithms and trialed several of them that you can see here, for example, logistic regression and neural network. But random forest was the one that works the best. And in the yellow one here, which ended up being the final version that they went with, it did about 42-43% better than the random allocation, and still about 3 times better than what Mindful Chef was using before. So it was a clear success of this algorithm in making the selection over what already existed. And also I should mention that the random forest plus star here was what they estimated, the team estimated that they could have developed given a little bit more time. But the time was limited here, and therefore the team decided to instead, as I said, focus on making sure they could deliver something that was full in its implementation and that was ready to use for Mindful Chef. So they went back and said, okay, we'll settle with the one that's already 3 times better than what already exists, and then we'll make sure that we wrap this into something that's useful. So what they ended up then doing was to wrap this trained model into an API. This API plugs in JSON files on one end, and in the other end just outputs the selection that it recommends. But this in itself was not enough, because it would be dependent on which operating system it sits in, and it depends on a number of machine learning libraries. And of course, if these were changed, then their model might break. And so to make it even more future-proof, they then wrapped that into a Docker container, which in itself contains its own operating system, its own machine learning libraries. And this meant that even if things around this Docker container changes, this container will remain solid and will continue to deliver an output. And all of this delivered within 4 weeks of actual work with a team of 4. So from our point of view, a great success. And Rob, maybe you can tell us a little bit about what it meant for the company.
Yeah, absolutely. I remember seeing the initial feedback from them, and that exact chart with the meatiness and soupiness, and think, well, we don't ship many soups, and so the way that Kim's described it, it took me a while to get my head around exactly what was going on here. But actually, there were about 20 factors, I believe, that were kind of in that 2-dimensional space that it's easy to contextualize and understand. But actually, within the kind of machine learning model, there were 20 factors altogether. And once it goes above 3D, it becomes a little bit hard for us to sort of contextualize what those clusters look like. But that's sort of how the model fitted together. And then it was just so interesting for us to think that actually every user behaves differently on how they jump around the menu on offer, and you know, whether they're very adventurous and people who really like to eat one end of the scale to like completely different recipes week in week out. We thought, like, wow, there's a lot of potential here for us to start to tailor our menus to each customer. So I guess from an individual's perspective and from a company perspective, what we're really doing is looking to improve like the customer experience, which from a commercial benefit, obviously happy customers means that they're going to buy more meals from us. So that was sort of one outcome that we were looking as like a measurement point to say, with the new recommender, if we recommended better recipes to customers, like would they be more excited about next week's menu, and therefore potentially make more purchases with us. I guess it also helps to boost loyalty. We want to be like a curator of great food for customers, and so that's sort of another thing that we were really looking for, was around like customer retention, and could we, both for existing customers who are there making active selections, but also customers who have left and are potentially need to be enticed back to the service, if we had a better idea of the type of recipes that they wanted to eat in any given week, that might also help us be more relevant to them. Flipping it around to actually focus on where we could also apply the data, was actually when we were then looking at, Chef Louisa was looking at a given week's recipes. This same model that would be there predicting, or like wanting to suggest types of recipes to a customer, might actually be able to influence back on recipe design and say, actually, I've got loads of customers who I would really want to give a meaty soup to this week, but there's nothing on the menu for the recommender to offer. So maybe you can actually change the menu around this week to allow the recommender to sort of achieve its goals. So that was like a sort of a project that we haven't started on yet, but one that was kind of, we were made aware of, that this, like the power of this recommender could also be like flipped around to help the kitchen team deliver, I guess what we think people want to eat in that given week. And then the final thing then is around, if we can suggest better recipes from the outset, that results in less customers changing recipes. And obviously when we have 16 recipes on the menu each week, and then that's 16 for one person, 16 for two person, soon to be 14 for family, you're up to 48 different meals. And as customers make last minute changes, because they go, oh, I don't fancy the ones that you've recommended, I'm going to go for something completely different, that obviously makes our like demand forecasting and our buying and like working with the growers that we grow, like who grow all our fresh produce, that makes it really challenging for us when 3 or 4 days before a delivery, the recipes are changing around. So we were also hoping that at some stage to bring the fact that we can suggest better recipes into our demand forecasting, to allow us to have more confidence that a customer on an individual basis, but then on on thousands of customers basis, will actually choose the recipes that we've selected for them sometime out. In terms of how it might look from a mathematical perspective, which the guys used at the end of their project, what we knew from the data was that customers who chose their recipes, presumably chose the recipes that they wanted to eat, had a far lower attrition rate, so i.e. like a survivor rate almost, a chance of buying the next week, than customers who didn't make any active selection, so they chose they had the recipes that the system selected for them. So we used that to basically benchmark between the two, our existing model, and how an improvement to the auto allocation might look. And how that netted out was, over the course of a year, it might look like sort of 1.6 more box purchases like per customer, which adds up very quickly for a business of our size. So from a commercial impact perspective, we were like absolutely thrilled with the outcome of the project, and we're super excited to now have it live. I don't know whether it's worth talking a little bit. Kim, shall I carry on about how we've extended the project since? So I mean, so after the 5-week project finished, we were super impressed with the kind of the outcome and I guess the potential to improve customer experience for the Mindful Chef community. So we've actually carried on working with a couple of the data scientists who are now kind of getting that model into production and making sure that it's actually ready for real life data. And we're just about to kick off now with kind of A/B testing against our current recommender, and that's when we'll have like real life data to report back on to see whether that 1.6 boxes really is a an accurate model or not.
Yes, great. And it was a fantastic case study and something we were very excited to work on and to continue to work on. So yes, to summarize the presentation, Pivigo worked with Mindful Chef and a team of 4 data scientists in our S2DS program to figure out an even better way to suggest food choices to Mindful Chef's customers through the new ways of thinking around the data itself and how one could collapse them into these smaller dimensions that do make sense in some sense, and also this curiosity parameter, which is apparently something that tells us a lot about who we are, which I can well imagine when I go to the restaurant myself. I'm probably one of those that do quite small jumps. I know what I like and I tend to stick with it. But also, of course, it ended up being a great project for Mindful Chef and hopefully also for Mindful Chef's customers, who will end up enjoying their selection better and getting a better service in the end. So a project we were very excited about. So that concludes our presentation. We have